Welcome to Solidworks World. Yeah. So what we're watching here as a spacer is the 2018 Classic Tetris World Championship. These are some of the best here. You can see both these guys are hyper tappers. That means they can tap the over arrow like 30 times per second. And that's what you have to do to play at the level they're playing at. So if you have like 2 years and you just want to burn off your life and you want to learn how to hyper tap, these guys would be the guys to watch. It's a pretty exciting contest, but I'm afraid I'm not going to be able to let you see the end. Who's going to win? Who do you think? Joseph, Corian? I don't know. It's pretty close. Corian's got the experience, but Joseph has the youth. Man, look at that tenacity. Look at that build. It's amazing. Boom, Tetris for Joseph, right? It's so cool. Oh, there it was. Boom, Tetris for Joseph.
And Joseph also got one.
All right. So let me just boot up Camtasia here. I'm going to record this for you guys so you don't have to feel too crazy about
Joseph looking over at Corion's screen. You're right.
Whereas Corian, if you notice,
we don't see that too often with players.
What's going to happen? I hate to block the screen.
Develop that skill early on.
Corian just staring straight forward at his screen.
All right.
Doing his thing.
All right. So how is Joseph going to handle that? Those right two columns, I see. So he's going to burn a little bit to get himself set up for more Tetrises.
Crazy.
You know, again, some unfortunate placement.
I know. Sorry, I'm blocking the screen. We're not going to know.
Just
oh yeah, I did it again.
Force
Sorry.
The burn right there. You saw.
We're driving closer to 130 though. The transition's going to happen.
Test. All right, this thing's picking me up pretty good here.
Boom, Tetris for Joseph. He's right there. There it is. Transition for Joseph.
Boom, Tetris for Joseph.
And Corion's right behind.
Yeah.
His playfield's in good shape, so.
And we're going to do full screen, right? I'm going to record this for you guys so that you can just watch the recording. I'll try to post it tonight.
For that S piece, and it wasn't coming in time. So now he's got to do some clean out. He's looking for the I piece.
All right,
now,
we're at 10:30. We're going to get going here. Sorry, guys. Boom, Tetris for Toby, right? All right. Welcome, everybody. Welcome to SolidWorks World 2019. My name is Toby Schnars, and I'm going to be showing you some tips and tricks. Like I said, I'm going to record this so that I can post it for you tonight. I love taking notes, so I encourage everyone to take notes, but if you don't want to, if you want to just sit back and enjoy your first session at SolidWorks World 2019, I'll make it a little easier for you. And my new friend in the audience, what's your name, sir? Robbie. Oh, no, the guy behind you. Sorry, Robbie. I'm giving you your shout out in a minute. What's your name? Zachariah, and he's going to be recording it too, so you're going to have multiple angles of this presentation, hopefully. So my name is Toby Schnars. I want to get you guys started with some tips and tricks. How many people are here at SolidWorks World for the first time this year? All right, a lot of people. That's awesome. How many people have been here before? Okay, good, a fair amount of people. How many people didn't raise their hand for either of those questions? Yeah, that's my punk rock crew. What's up, Bill? Yeah, what's up? And I also do want to give a shout out to Robbie. So maybe Robbie, if you want to stand up and just wave to everybody. Robbie's here and he just got his CSWP on Thursday. So congratulations, Robbie. That's awesome. And he's also reminded me that if you are here for the first time, you have the opportunity to take some certification. So make sure you take advantage of that while you're here. All right, so let's get into this presentation. Here's what the agenda is going to look like. We're going to do an intro, we're going to do tips and tricks, and we're going to do a conclusion. So here's the intro, okay? This is some really important info. I guarantee you're going to be at a presentation this week where somebody's going to give you their whole life story. Like that's what you came to SolidWorks World for. So you're going to see lots of fun slides like this, but I'm not going to give you this slide. I'm just going to say that I am on social media. So if you guys want to follow me on social media, you can basically just look up SolidWorks Toby. That's where the YouTube page is. That's where I'm going to try and get the video up tonight. So if you guys want to watch the video of all these great tips and tricks, I'll give them to you tonight. I also had basically no idea how to put together this presentation. It's really hard to capture like little tiny tips and tricks. So you can see, look at this slide deck. I just kind of like let my brain vomit into PowerPoint. And I came up with all these different ideas for tips and tricks that I want to show you today. But along the way, if you have any questions, we can definitely deviate from the plan. I don't think we're going to be able to get through all the material, but hopefully by getting some feedback from you, we'll get into important topics that are going to help you do your job a little quicker. All right, so that's the intro. Was that good? All right, let's move on. Tips and tricks. So this is what I looked like when I was a little bit younger. Young Toby. This is from 2012. No, 2003. So that's young Toby rocking out on a bass guitar. And here you can see a model of that bass guitar. And that's what we're going to use to get started today to talk about assemblies. Let's do a quick vote. Who wants to do this whole presentation doing all videos? Just me showing you videos the whole time. And who wants to see live action in the software? Yeah, that's what we want to see. So let's get into the software and talk about some live action. First of all, just a quickie here, talk about trimming up the tree in Solidworks. So this is something just real quick and easy you can do, but we've all been in this spot where you have to take this scroll bar and move it over. So I'm talking about this area down here at the bottom, this scroll bar down here. You know, like it always jams over to this side when you want to do something important, and then you have to go down and find that and move it back over. So just a little quick thing that you can do to address that is you can go into the top of the tree here, do a right mouse button and go to tree display, and then you have these qualifiers here for component configuration and display state. And if you just turn them off, it'll trim the tree. It'll make it a lot easier, and you won't be nearly as likely to come up with that scroll bar at the bottom. Look, he went away. See you later, buddy. You're gone. Sorry. So no more scroll bar. So that's just a quickie tip to get us started here. Let's move on. Of course, again, like I said, along the way, I'm not going to ask if there's any questions. I'm just going to encourage you guys to shout them out if you have questions. And then I'll try to repeat the question for the video recording. All right, let's take a look at another one here, Divorce Toolbox. So this is something that, again, another situation that we've all been in. You open up an assembly and you get a result like this. So let's take a look at this amazing assembly of the bass guitar here. And see what I'm talking about right down here? So we've got this issue where the hardware came in too large. So why does this happen? Does anybody know why this happens? Not units. Good guess, but that's not why. It happens mainly because you do something to the file or the file name, and then you ship somebody the assembly without the toolbox parts. So for example, if you go in here to File, Pack and Go, there's a qualifier in Pack and Go for include toolbox components. So you're like, I'm going to do a Pack and Go and send this to my coworker, but I forget to hit that check mark. Then they receive the package. And what Toolbox is supposed to do is interpret that toolbox information and then generate new sizes automatically. But it doesn't always do that. And when it doesn't do that, you end up with this result here where you have the hardware that's too large. So if I go into this subassembly, this is another kind of cool trick that you can do in SolidWorks, right? How do we get to the subassembly? We click here and then it highlights it over in the tree and then we go find it in the tree and open it, right? Well, with subassemblies, you can just click on the entity, the face of one of the parts, and then this list here will show you a list of all the different subassemblies that are included. So for example, this bridge here is a bridge subassembly that has more subassemblies inside of it. Let's say I pick one of these parts here and I go to open. You can see that it shows me the full expanded tree here going down to all these different subassemblies. Let me try and do a live zoom so the people in the back can see that. So if I click this face here and then I go to open this guy, see subassembly, or the individual part. How many people knew about that? All right, good. I'm getting more than half the crowd. This is what I like to see. You know about that one, Gary? Get out. All right, so we're going to open up this guy here, and we're going to go to this subassembly here. So we can see here the subassembly, the way this was created was with some toolbox parts, and obviously the toolbox parts are not the right size. Now, if these come through as as genuine toolbox parts, then it might just be a matter of going into the right-click menu here and then choosing Edit Toolbox Components, and then you can drive these down to whatever the appropriate size is. So let's say these are like number 632. That's fine. That's fine for our example today. All right, so I'm going to move this guy down into place, and then I'll do the same thing here. Right mouse button, Edit Toolbox Components, and then I'm going to move this guy down into place as well. So now that we've got these guys in the right place, we don't want to have this issue with Toolbox anymore, right? So we're going to try to divorce these parts from Toolbox. So how do we do it? Well, the first instinct is just to open up this part file and then do a Save As. So we go File, Save As. This dialog box comes up. It says you're going to be replacing the reference in the assembly. If you don't want to do that, do a Save As copy. It talks about that. Well, that is what I want to do. So I'm going to do a Save As here, and I'm just going to throw this guy onto the desktop, and I'm going to call this one New Screw. Very good name, right? I'm never going to lose that part in the shuffle. All right, so New Screw, and then we're going to go back here, and we're going to save the assembly. So anytime you want to see the formula for an assembly, you go here to File, Find References, and this will give you the formula for the assembly. And we can see here that this part is coming off of my desktop, New Screw. Okay? So now I'm going to save, and I'm going to close this assembly. And I'm going to close this assembly as well, just so that everything is unloaded from memory. And then we're going to open up, so I'm saving again just to write all those paths. And then we're going to open up our system options, and we're going to look at our system options under Whole Wizard Toolbox. And there's this option in Whole Wizard Toolbox that says, make this folder the default search location for toolbox components. So what this means is, if I go to open up that assembly again, where is that screw going to come from? It's going to come from the inappropriate location, right? It's going to come from not the desktop, but from the toolbox location. So we go in here, I set my filter down here to just filter my assemblies, and we go to this input plug cover assembly, open this guy up, and we go to File. You can already see it in the tree, right? The model's not called new screw. And if we go here to File, Find References, we can see here that now this thing is referencing the incorrect location. All I did was save it, close it, and reopen it, and I'm getting a different file reference. How many people have struggled with this, with Toolbox file management? Okay, good. So a number of you are gonna benefit from kind of resolving this headache. Now, I'm not saying you should always do this. Every situation is different. And there's certainly gonna be situations where you wanna continue to utilize and maintain Toolbox. But if you're doing designs on the fly, there's a lot of spots where knowing how to do some of these techniques is very helpful. So here what I'm gonna do is I'm gonna close that assembly, and the first thing that I'm gonna do is I'm gonna go here to my options, and in my options I'm gonna go to Whole Wizard Toolbox, and I'm gonna say, don't make this folder the default location. So I'm gonna clear that check mark. So we say okay here, and we go back to File Open. Here I'm just gonna press R on my keyboard, right? That's a really good shortcut to know. R on your keyboard opens up your recently accessed documents, so then I can just click on that guy there, and now you can see we got new screw again. Right? So that's what we wanted. So that's your first tip regarding this topic of Toolbox, is understanding how that checkmark qualifier works to divorce your components from Toolbox. Now if we go in here to File, Find References, you can see here that now we're looking at the appropriate location for that screw. Now, if you want to take this one step further, you can remove this flag that exists when you have Toolbox parts. You can see anytime you have a Toolbox part, when you look at that Toolbox part in the feature tree, or when you look at it in File, Find References, it shows up with that little bolt icon instead of a standard SolidWorks part icon. So that means that part is going to be consumed by any qualifier for Toolbox operations. So for example, if I go here to File, Find References, if I go here to File, Pack, and Go, once again, you can see that new screw is not included in this list. Why is it not included in the list? Because I didn't choose Include Toolbox Components. So you can actually use this trick in two directions. You could force certain components to become Toolbox components, or you can tell existing Toolbox components you don't want that flag to be on the file anymore. So include or exclude those parts that have the flag on the file. So the way that we do this is there's a little utility that ships with the SolidWorks software. It's really easy to find, right? It's in, C program data, or is it in C program files? We'll go into program files. And then I guess maybe it's in 2019, SolidWorks. Really easy here to find this. Toolbox. I don't know why everybody doesn't know where this one is. Data, utilities. Okay, here it is. And it's called Set SLD Doc Prop. So if we choose that Set SLD Doc Prop, and then we add files to this list, you can tell this is like a really old program that not many people use anymore because it's got this weird old dialog box interface. But if we say show status here of this document, you can see it says the part file is called new screw, and is it a Toolbox part equals yes. It says standard, but that just means yes. So we can take that Toolbox part and then we can say we want that to change to no, and we want to update the status of that part. And now we say show selected status, and it says no. And now we go back into our assembly. So back in here, we press R and we open this assembly again. And now you can see that part in the tree no longer shows up with that little bolt. And what that means is that this part's never going to get scooped up by those Toolbox operations. So we've all been in these spots where we do a pack and go and certain files get excluded, and a lot of times this is the culprit. So understanding that you can remove that flag, or you could attach that flag to a part that's not a Toolbox part, can be a really helpful tip to help with these kind of max operations. So we go here to File, Pack, and Go, and now you can see that new screw part file is just automatically included. It's right here. I didn't have to choose Include Toolbox Parts. It's always going to go with that file. If I go to check that file into the vault, PDM isn't going to see that it's a Toolbox part and handle it differently. It's just going to see that it's a standard part. This is a great way to utilize Toolbox to just go in and grab one-offs and stop them from being regular Toolbox part files. Cool? Everybody cool with that? All right, good. We got some thumbs up. I like that. All right, let's go back to our R key and open up our assembly and take a look at some more of these great tips and tricks. So hide and show a file in assembly. I know that I spend a lot of time visiting customers, and a lot of times I see customers doing things the long way. So this is kind of what generated this list of tips and tricks. And one of those things that I see people doing the long way is this hide and show function. So all you have to do to hide something is just hold your mouse over it and you can press Tab, and that item gets hidden. If you hold your mouse over the area where that part was and you press Shift Tab, it comes back. You know, hiding something isn't that big a deal because you can just click on it and you can choose hide, right? And then it's gone. But what about showing that component? What's the long way? The long way is we have to go into the feature tree and dig through the feature tree, right? Find that component, click on it, and choose show. You don't have to do that. You can just hold Shift Tab. And you don't even have to know where the thing is. You just hold Shift Tab and move your mouse across the model. And when you get near something that's hidden, it'll come back. So I'm holding Shift Tab and I'm just dragging across the model there. I don't think so in drawings, no. Like hiding individual components. I mean, let's find out. It's a great question. Our first live question. Let's find out. So let's open up the same assembly we were working on a moment ago. Nope, that is not the assembly. That's called clicking too fast. All right, here we go. And then we'll go File, Make Drawing from Assembly. This is the best way to make drawings. File, Make Drawing from Assembly. I always visit customers and see them doing things differently, and sometimes I just let them go. Sometimes I tell them. All right, so now we want to do Tab to hide now. So you can still hide components in drawings this way, but we can't. Let's see. Oh, we do what? Right mouse button hide? Is that how we hide that component? There we go. Okay. Yep, great question. Oh, and the question was, does that work in drawings? You guys got to remind me to repeat the questions. What's up, Robbie? In the drawing? Is that what you're saying? Yeah. No, not necessarily. Yeah, it's on a per component basis. Yep. There are things that can happen that can cause components. So the question was, is there any automation of other components becoming hidden? There are things that can affect that, like in drawings, there's an option that's kind of for performance. So I can't remember where this option is, so I'm going to go up here to search options. This is great if you don't know where any options are. I always tell people, if you want to work tech support and you learn how to use this box, you can do 90% of the job, right? Because people always would call me in tech support and be like, where's that option to auto hide components in drawings? And I'd tell them and they'd be like, how did you know that? Just know the software. Oh, what that option? That option's in system options under drawings, of course, right? Everybody knows that. So this automatically hide components on view creation will hide components that you can't see. So if you put a cell phone in, all the internal PC board and everything would become hidden automatically. You'd see it hidden in the view tree. So there are options to do that, but just doing a regular hide shouldn't cause that. All right, cool. So tab to hide, shift tab to show. Here's another one. I always see customers doing this. They use the measure command. If you don't know about this one, you're going to love this. How many people know about this already, just from what I'm showing here? Okay, good. Good. So a lot of people don't. I didn't see all the hands go up. So this is a really good one to know about when you're in SolidWorks. All you got to do to measure something really is just click on it. So I'm going to click on this circular edge, and then I'm going to look down here, and I'm going to see the diameter of that circular edge is 0.66. 0.666, right? So if anybody comes over your desk and they're like, how high is that knob above the pick guard? You just pick the face of the knob, pick the face of the pick guard, and then look down here. And you say it's 3/4 of an inch. So you don't need to go and bring up the measure command, turn off the measure command, bring it up, turn it off. You just can use a single click and it'll tell you where most things are. It'll tell you the distance between two faces. If they're not parallel, it'll tell you the angle. So that'll kind of help you figure out if faces are parallel. So if they were parallel, it would give you the distance. If it gives you an angle, then one of them's askew. So these are cool tips that you can use to save some time as you're going through your workday. It should be on, it's part of status bar. So if view status bar was turned off, then I could see it not being there. So if we go in here to view, let's see here. I don't know how to turn off status bar anymore. Here it is. UI status bar. That would be the only way, yep. So that's a great question. And the answer to that question, and the reason it's such a great question, is because your precision in dimensions is not the same as your precision for the system. And that's why there's a difference between, in options here, under document properties. That's why you've got a section called units. This is your system precision. And then you've got a section called dimensions. This is your dimension precision. So the thing that's weird about this option is there's some entanglement that occurs between them. Like if you change one, sometimes it changes the other, and sometimes it doesn't. I once worked with this guy from MIT. He was my coworker, and he and I cranked on this for so long, and we were like, I don't know, there's a ghost. It just causes it to go. The closest we can figure is if you do it here first, then it pushes through to dimensions. But if you do it in dimensions first, it doesn't push back through to system options. But the answer to that question is your precision is going to be based on your system options for the status bar down here. So if I pick this face and I pick this face, you can see it's at 0.75. And that's it, 2 places. And then the precision for the dimensions is going to be here in that other section in your document properties dimensions. Yep, great question. And the question was, does that affect your precision? I have a really bad habit of forgetting to repeat the question. All right, cool. right, here's another one, fully defined sketch. This is one that's very, very near and dear to my heart. All right, I actually once wrote a song about fully defining your sketches, and it's if you want to look it up, I encourage you to look it up. It's a great song. It's on YouTube, and it's a really good song. I just want to take a picture of everybody right now while I got you smiling, because I think by the end you're going to be like, what is up with this guy? But right now I got you smiling. But yeah, this is a great song. You can look it up on YouTube. You just look up SolidWorks sketch song or SolidWorks fully defined sketch song. It's an original. It's not a parody or anything. It's a true original. But I think it's very important to fully define your sketches. And a lot of times when we're working in the software, we just need to get in there and just create some basic geometry. So let's say I get in here. I'm going to make a new part in inches. I'm going to go front plane, begin a sketch, and I'm going to sketch center line here. So I'm going to go S key, I'm pressing the S key there, which we'll talk about in just a bit, and then I'm going to create a center line, and then I'm going to create the basic geometry for a new knob. So I'm going to come over here, come up a little bit. I'm just going to keep this really simple, so I'm just going to, let's see here, I'm going to just make a regular arc that comes off of this guy. So I'm going to do line, I'm going to click on this point here. So line, click on this point here. Then I'm going to come away from the point. Then I'm going to come back and hold my cursor over that point and then come off of it again. And that puts me into an arc. A lot of people know that for the tangent arc, but it also works in all the different directions. Perpendicular arc, reverse tangency arc. It works in all different directions. And then I'm going to come up here and just kind of close off the sketch for this knob like so. And then I'm going to put in a smart dimension that goes for the diameter down here for where this is going to hook onto the pot, which I can't remember what that value is. I'm just going to make it a 1/4 inch. And then the overall height here, I'm going to make this 0.75 inches because we know that one. Okay, and now I'm going to right mouse button in the background and I'm going to say fully defined sketch and I'm going to say calculate. And SolidWorks goes through and adds the rest of the dimensions. So I went through that a little quick. I'll show you that one again. It's right in the background there. So I'm going to go to right sketch. The sketch is currently underdefined. I'm going to go to the right mouse button in the background and I'm going to say fully defined sketch. Now you have all these cool controls that you can utilize over here. So you've got controls for like what types of relationships will be automatically added, so that way one of the ones you can avoid there might be equal or collinear. If you happen to have certain components that are already equal but you don't want them to be equal, you can get rid of that. Or like perpendicular, that might be another one where you just want to use vertical and horizontal. You don't want it to automatically put in perpendicular. And then down here you can control where the dimensions are going to be datumed from. So this is going to be a dimension that's going to originate from point 1 at origin. Well, this is a circular revolve part, so maybe it would make more sense for me to use a center line option here for my horizontal datum. So I'll go here for my center line option, and then the other one can come from the origin. That's fine. And so now you see, instead of it putting in a true linear dimension, it's giving me a diameter dimension. It does default. Yes, I did it for you. It's already there. Now the question was, is there a way to make it default to the origin? The answer is it usually does, but I've had spots where it doesn't. I've had spots where you do fully defined sketch and it just doesn't pick up certain entities, and then it gives you a dialog box that says, couldn't get everything, basically. So it's a great tool. It can save you time, especially in spots like this, but there could still be some additional little touch-up you need to do. Is that what you're running into too? It doesn't always do the origin? Yeah, I mean, it could be pre-selection also if you happen to have something pre-selected, but I've been in that spot too where it seems like, it's like, why is it picking there? Maybe it could also be if you're on a plane that's not orthogonal to the origin, if you're on a compound angle plane, that could also maybe be causing it not to pick the origin because it can't get a good projection off of there. Yeah. This one won't overdefine your sketch. It'll stop before it overdefines your sketch, or it should. Are you saying you've experienced that where it does? I mean, if it doesn't work properly, you're just going to have to go back in and touch it up. That's the best answer I can give you. Yep. Because like in this spot, you saw I had a couple of constraints already, and it went through and it didn't redefine them or re-overdefine them. It could also be maybe if you utilize the exclusion option here for your relationships. So if it's overdefining because it's making a line collinear that already has a dimension on it, maybe if you exclude some of them, you'll have more luck. Might be the way to go. Yep, great question. And the question was, how do you not overdefine your sketches with that thing? All right, we're going to now revolve this thing. This is just something else that you should know about. You can see this dimension here is a linear doubled dimension of 0.882. Sometimes we use these linear doubled dimensions if we're going to do an extrusion and then do a mirror downstream. So if I'm going to do a mirror of this feature about that face, then it might be valuable to have that 0.882 from the original half sketch. But in this spot, what we're going to do is we're going to be doing a revolve. So right there, I did a Control Z, that's undo. It's like the second most commonly used shortcut, second to escape, right? So undo, Control Z, make sure you know that one. You can go back pretty far in SolidWorks now too. I remember in the old days, people were always like, it doesn't even work more than 2 features. But now it goes back pretty far. So now I'm going to do a revolve. Now, when I do this revolve here, you're going to see that I'm not going to pick the center line, but instead I'm going to pick this other vertical line that's behind it, or I'm going to try. Let's see if I can get there. Select other. Okay, pick that one. So I'm not going to pick the center line. I'm going to pick this solid line, and I'm going to hit the green check mark. And you'll see that that 0.882 is a linear doubled dimension. And now I'm going to edit that feature, and I'm going to go back, and I'm going to pick the actual center line. So I'll pick down here and get the center line. And now we're going to see that that 0.882 is a diameter dimension. So what happens is if you dimension to and revolve about the same line, if you dimension to and revolve about the same line, then SolidWorks automatically adds in these diameter symbols and makes them diameter dimensions. Just a little nuanced thing, but in case you didn't know that, that's what qualifies it. If you've ever been in those spots where you're like, how come it left it? How come it left it linear? You might have just revolved about a different line than the center line that you used for the doubled dimension. What's that? It still looks like a doubled dimension. So what does it look like in the sketch? So it still looks like the double dimension in the sketch, but it does add the diameter symbol. Yep, great question. All right, so now I'm going to change the color of this part just real quickly here. I'm just going to click on the little beach ball up top and then change the color. Just in case you didn't know how to change colors, that's like a quick, easy way to do it. There's lots of ways you can change colors, but that's a real quick, easy way to do it. And then I'm going to save this part. I'm going to call this one New Knob, and I'm going to call this Gary's Mod, which has multiple levels of jokes in it. And then I'm going to add a feature here called a mate reference. So mate references are awesome in SolidWorks. They're really easy to use. And what you're doing with a mate reference is you're preloading the component to be added to an assembly with a mate. So I'll show you an example of that. I'm going to pick this face here, then I'm going to press the S key, and I'm going to go to Reference Geometry Mate Reference. So it's right there in the S key command. And when I go to Mate Reference, so I pre-click this face, go to S key, Mate Reference, I'm just going to leave everything else alone. So all I'm doing is I'm just in a spot where I've got a component, it has a planar face. I know I'm going to drag it into an assembly and mate it to a planar face. So I'm just kind of pre-cooking that and saving myself for the next step. So I'm going to save that right there, hit the green check mark, save this part, and I'm going to close this part. Oh, now I need to insert this part. Crap. I didn't mean to close it. I just wanted to drag it in from the other window, right? What should I do? Anybody know? R, right. So we press R, which is your recently accessed documents, and you can drag and drop right from the R key into your assemblies. Pretty cool, right? And now when I take this component and put it over a planar face, SolidWorks automatically knows that I'm trying to mate that to the planar face with a coincident mate. Maybe. Drop in there. Okay, that's exactly what I wanted. No, there, with a coincident mate. I was expecting this beautiful preview to come up when I did that. There you go. So I just drag and drop that in there, and it just drops it right into place. When I drop it, SolidWorks says, you pre-cooked this part with a mate reference. You didn't do anything else with it. You can do a lot of other really cool stuff with mate references, but I didn't do anything else. I just pre-cooked it with a default mate reference, and now when I drag it in, I'm going over a planar face. So it says, okay, you want to mate these two faces. How do you want to mate them? Do you want it to be a distance mate? Do you want it to be parallel? You want it to be at an angle? Or the most common one, do you want it to just be a coincident mate? So if we take this idea one step further, we can utilize the fact that in SolidWorks, whenever you have an intersection between a cylinder and a plane, you get this special scenario for mate references. So this is a cylinder, this is a plane, this edge is at the intersection of those two faces. And what this special scenario lets you do is it lets you create a mate reference by picking a similar intersection. So let me edit this definition. Actually, I'm going to delete this. You don't have to delete it, but I just want you to see how easy this is. So S key, reference geometry, mate reference, this edge, green check mark, save, close. That's all I did. I just picked that edge, added the mate reference, and closed it. And so now when I do the R key, I'm dragging this part in, which has a mate reference at the intersection of a cylinder and a plane. I'm dragging it onto a part which has an intersection at a cylinder and a plane. Dragging it onto a part which has an intersection at a cylinder and a plane. And SolidWorks goes in there and it automatically adds two mates. So this part can only now rotate. It cannot move up and down because it added two mates. And those two mates are to those two faces. So you can see there's a concentric mate between those two faces, and there's a coincident mate between those two faces. What do you think? Is this going to save you time when you're putting parts together in an assembly? Yep, thumbs up. Everybody's got, yeah, I love this. This is a great polling system. Awesome. Yeah, so this is a good workflow. And a lot of the things that I do, a lot of the things that I teach to my students are workflows. They're full workflows. So in this example, I didn't just teach you about using a mate reference. I taught you about using a mate reference with a planar scenario, using a mate reference with an edge scenario, and also using the R key to bring those components back into your assembly. You know, you're working on a component, you save it, just press the R key. You don't have to do insert part and then go browse for that part. You just press the R key and it's right there. No. The question was, is it required for the other part to have a mate reference? And the answer is no. In fact, you don't actually have to have a mate reference on either of them. You can do what's called an, what were they called? Smart mate. So you can do what's called a smart mate, which is where you start dragging this edge, then you press Alt. Thank you. Then you press Alt. And then you can see that this part now has like a little paper clip underneath it. And now that edge is at the intersection of a plane and a cylinder. And I move it onto this edge, which is at the intersection of a plane and a cylinder. And I can get that smart mate to happen between those two faces that way as well. Neither of those parts have a mate reference. So that's a great question. I heard another question from over on this side. Oh, hold on 1 second. It does not. Nope. It's got to be at the intersection of a plane and a cylinder. It's a special edge condition. Oh, sorry. Thank you. And the question was, does it work if this edge is filleted? Can you set up that same mate reference if this edge underneath here is filleted? If either of them are filleted? No. Yep, that's a great question. Another one somewhere? Lock auto rotation, I think was the question. I can't remember if it's in there or not. If it is, it'll be here. But I think it's only there if you do like a cylinder mate reference. So let's say I take this, and then I say I want that to be a concentric mate reference. That still doesn't show up. So I don't think it is. I think you're going to have to go back in after the fact and do that. So the question was, can you auto-lock the rotation after you drag and drop that in? I think you're going to have to go back in here after you're done and then do lock rotation. But you can just do that from a right click. You can just right click on that guy and do lock rotation. And I think you can even do it in bulk. Like you can multi-select mates and do lock rotation. And I think you might even be able to do it up here. Right mouse button, lock concentric rotation, and that'll rip through the whole tree and lock all of them, I think. Wait, well, these didn't fill in. Maybe these are older. These guys are too old. When was this feature created? Let's look. Right mouse button on any feature, go to properties. So this was created back in 2011 by T. Schnars. So you can always see when any feature was created. You can see when a sketch was created. If there's an underdefined sketch, it's one of your coworkers. And you're like, hey, Bob, why didn't you fully define this sketch? I didn't do it, right? And then you'd be like, well, somebody on your computer did it. Somebody jumped on your computer and did it. Yeah, it's right here, your name. It's your computer. All right, so let's keep going here. All right, so we talked about fully defined sketch. Make sure you look up that video. I want to see if I can get that into the 3 digits for the views, over 100. We're getting pretty close. The quick color change, you just go up and hit that little beach ball up at the top. You can change the color. Mate references are awesome. You can access them from the S key. Use the R key to bring in your recently added parts. This is another really good one to know about. Copy parts with control and drag. I think I did that, right? I did a control drag in the, maybe I didn't talk about it. You can copy parts by doing control drag. All right, covered that one. No, you know, it's funny. A lot of people don't know about that, and I once taught this tips and tricks class to some pretty experienced users at one of my customers, and I did it from the tree. I grabbed the part from the tree and did a control drag, and he just about fell out of his chair. He's like, are you kidding me? We've been doing insert part and browsing for that part for years. That's all we had to do was just control drag from the tree. That's awesome. So hold control and drag if you need to bring in another copy of your parts. Okay, buried parts. How many people have been in this spot? All right, so there's a little tiny screw there inside of that rectangular prism. How do we get that part out of there? Right? How do we work with that part? So there's a few ways that you can do it. You could isolate that part. Usually it's a part that you just brought in, so you can see it's this part here. You could do a right mouse button here. You could isolate that part, and then you could move it into the desired position. But one trick that works that's been in the software forever is you just click on the name of that part in the tree, and then you click the move command. So you're like preloading that part in the tree, and then you click the move component command up here in your SolidWorks assembly toolbar, and then just move it right out. Pretty cool, right? That's nice, right? Robbie likes that one. Robbie approved. That happens all the time, yeah. And SolidWorks has added other cool stuff like making parts transparent when you're mating them to help with this issue, but this is one that's tried and true. Open subassembly, we talked about this a little bit earlier, how to go into your subassemblies, do an open subassembly. File, make assembly from part. This is definitely the way to go when you're working with assemblies. If you need to make a new assembly really quickly, you just get that part file open. You just get SolidWorks open. Nope. All right. Third method. All right, let's minimize PowerPoint. Here we go. All right, we got this. We can do it. All right, let's just not talk about that one. Here we go. Flag. Okay, there we go. Escape, the best shortcut ever. All right, so if we go to a single part file and we want to make an assembly out of that part file, we just go up here to File, Make Assembly from Part. Then you choose your assembly template, and then you hit the green check mark immediately. And that'll take your part file and drop it onto the origin. And once it drops it onto the origin, it does what's called fixed. So now that component is locked there in place for the fix command. Really easy way to work with assemblies. So I'm going to add a couple of Toolbox components to this thing. Let me go over to my design library here, and I'm going to add Toolbox. Actually, I'm just going to grab one from here. I don't think so. Is there? There's a check mark option? Let's do it. So the question was, is there a way to set it up so it doesn't fix it when you do that? That's the question, right? So we go File, Make Assembly from Part. Then was there a check mark over here or something? I think it's still going to fix it. There's one in the options. Doug for the win. I don't know. I don't know if there is. I'm not saying there isn't. I'm just saying I don't know if there is. That's how I do most of my tech support. I'm like, I don't know. Maybe. Just try it, I guess. All right, so let's see here. So another thing that we're going to do here is we're going to bring in some Toolbox parts. Let me just grab some Toolbox parts here. So we'll go into bolts and screws, and we'll go into machine screws, and we'll go into, actually, let's go to countersunk here. Okay, just drag and drop this guy in. I don't really care what size this is. The size doesn't matter, right? All right, here we go. We're getting crazy already. Oh, missed it. My shortcut failed me. My escape shortcut. Okay. And let's just make this a little longer. Wow, we're really getting dicey here with this opening presentation for 2019. All right, and it didn't made into place the way I wanted it to, but it's no big deal because we have quick mates. So I can take this guy here, hold control, take this face, let go of control, then this box shows up, right? That's for a lot of different quick commands have that, but quick mates is one of the best enhancements. I think it was in 2014, one of the best enhancements in the software. So all I did was pick, just like adding sketch relationships, pick one, hold control, pick the other, let go of control, and this box shows up. And we can go to Concentric. Okay, and the other thing that we're going to do is we're going to just bring in a washer here. So I realize I'm not fully constraining this thing. I'm just doing it for time, but I think you guys are able to hang, right? Right? All right, so now we're going to go here to, what's that? There is, yeah, sketches, fully defining sketches. It's not as important in assemblies because sometimes you want, yeah, I know, that's true as well. Very true. Touche. All right, let's lock it down a little bit more. I'm going to lock down the height here with a distance dimension. So I'm going to go here to distance, and I'm going to say that I just want it to be whatever it currently is. Again, using quick mates to save time there. So now what I want to do is I want to mate this face to the underside of the plate here. So how are we going to do that? We're going to rotate the view, click, click, rotate the view, right? But another way that we can do that is we can use what's called Select Other. Now, Select Other has been in the software for a long time, but its capabilities elude most people. Its functionality and how to use it properly as well. So basically what happens is when you use Select Other, you pick a face, either right mouse button or left mouse button. What's up, Angela? Welcome to the presentation. Hello, does that mean I have 2 minutes left? Or does that just mean I'm doing good? Oh, what's up, Andrew? I can't see you because the light's coming down weird. You're like an angel. All right, so when we're using Select Other, what we're going to do is we're going to click on a face, and then once we click on that face, we're going to pick this icon with the two squares in it. And what that's going to do is it's going to hide the face that we just clicked on. So you see here that when we go to this face, we click on it, it hides that face. Now, from here, we can either left mouse button or right mouse button. As we right mouse button, all the faces that we're right mouse buttoning on become hidden as well. It's almost like we're skinning this thing or turning it into a surface model. So you see all those faces that were on that wall previously have become hidden. We can rotate the model around. We can continue right-clicking. You wouldn't normally do this workflow, but it's just used to illustrate how the select other command works. And once those faces become hidden, you can select right through them. So for this application here, what I'm going to do is pick this face, select other. That face becomes hidden. And now I'm just going to left click, and what I've done is I've selected the face on the underside. So you just do a right mouse button or left mouse button, and you pick select other, and that face that you're on becomes hidden. Usually that's sufficient. So usually I could just pick this face here, select other, and then pick through and get that face on the bottom. But sometimes if you're in an assembly, there's multiple faces in the way. So what you can do to tunnel through all of them. So let's say I wanted to pick the top of the washer there. What I could do to tunnel through all of them is I could do a right mouse button, select other. Hold on, let me turn off real view for a second. Right mouse button, select other. Right mouse button, right mouse button, right mouse button. Now I can pick the washer. Now everything comes back. Cool? How many people knew that before? How many people know it now? Yeah, that's what I like to see. All right, so we're going to go here to right mouse button, select other, or left mouse button, pick that face, hold control, pick this face, and then we're going to do a coincident. So now I want these screws to populate all the way across here. So there's two ways to do this. There's the super easy way, and then there's the fairly easy way to do this. So the super easy way to do this is whenever you have a pattern in a part file, you can reuse that pattern in an assembly file. And a point-driven pattern in a part file looks like this. So if I go here to this face, begin a sketch, orient my view, S key, circle, give it a dimension here. Now I'm going to go S key, extrude cut. Then I'm going to go right mouse button through all, and then I'm going to immediately right mouse button again. That's another workflow we're going to talk about in just a few minutes. And then I'm going to start another sketch on here. And I don't have point on my S key shortcut toolbar, so I could add it, but I'm not going to. So we're going to add a bunch of points here like this. And then we're going to pick that sketch of points, and we're going to go here to our feature command, and we're going to say point-driven sketch pattern, or what's it called now? Sketch-driven pattern. And then we're going to pick this cut extrude that we just created. So you see we are able to pattern that cut extrude into the location of all those points. This is something that we do. This is actually the lesson we use to teach the fully defined sketch command, because this would be a great spot to do fully defined sketch. And then I'm going to say I want this to be my baseline for horizontal, and I want this to be my baseline for vertical. I know the screen's a little bit crooked right now. And then I want this to be ordinate, and I want this to be ordinate, and then calculate. And then it goes through and adds my ordinate dimensions to locate all those points. Nice, quick, easy way to do that using fully defined sketch. So this is a pattern that exists in a part file. And anytime you have a pattern in a part file, you can reuse it in an assembly file. Well, how does Hole Wizard work? Hole Wizard is a cut revolve. So here's the cut revolve sketch. Let me show that sketch, right mouse button, show that sketch. And then I'm going to right mouse button on that sketch, and I'm going to say sketch color, and I'm going to make it red so it really pops out. Sketch color is another really cool tool you can use in SolidWorks. So that's a cut revolve. And then this sketch here is a sketch of points. When you're doing a Hole Wizard, what are you asked for input? You're asked to pick the size, and then you're asked to locate the points. So really what a Hole Wizard is it's a point-driven sketch pattern. It's a feature pattern using a point-driven pattern or sketch-driven pattern. So what this means is when we go to our assembly environment, we can do a pattern here. We can say we want to make a pattern using pattern-driven component pattern. So here's the pattern types here. Pattern-driven component pattern, which means reuse a pattern from the part file. And then once we do that, we can say, what do we want to pattern? We want to pattern this and this. And what's our driving feature? It's this Hole Wizard feature. And look at that. It looks beautiful, right? It looks perfect. So the final thing you have to do here is you have to do what's called select seed position. So that's where you're originating the pattern from, because it's a point-driven pattern. So our seed position, we click that, all these little magenta dots show up here, and we just pick this one down here at the end, and there we go. We've created a pattern of a pattern. And what's cool is if we go back into this plate and we edit that Hole Wizard feature, or even just this sketch, and we start dropping in additional points here, the pattern's going to update in the assembly to take on those additional points. So there's the updated pattern in the assembly. So if you use Hole Wizard and you're populating those holes with hardware, you could use smart components. There's other ways you can do it. This is one that definitely shouldn't be overlooked. Now, the other way that we can do a quick pattern of components. So let's say it's not hardware. Let's say it's not Toolbox. Let's say it's not in these appropriate holes here. What we can do is we can use the command right mouse button, and then we can use the command copy with mates. Copy with mates. And copy with mates is a really cool one. What you do is you start out by picking the components that are going to be part of your copy, so the batch of components. And then you go next, and then SolidWorks says, all right, these components are mated together internally, right? There's a concentric mate between the washer and the bolt, or the screw. There's a concentric mate between the washer and the screw. So SolidWorks doesn't ask us to input that concentric mate. It only does the concentric mate between the screw and the plate. Right, there should be, if you think about it, there should be 4 mates here. So there's the distance mate coming off of the top of the plate. There's the coincident mate at the bottom of the plate. You can't leave. I'm not going to remember to repeat the questions. There's a concentric mate going into the plate, and then there's another concentric mate between the washer and the screw. Why doesn't that other concentric mate show up? Because it's internal to the grouping that I selected. Okay, the rest of the mates are external to the grouping that I selected, but this one mate is internal to the grouping that I selected. So now what I'm going to do is I'm going to say, when I go to make a copy of this screw and washer, I want the concentric mate, the new concentric mate, to be over here. And I want the new distance mate to be from this face. And I want the new coincident mate to be from, select other, the bottom face. And now, all I need to do is right mouse button, which means advance to the next, and I can do it again. So I could go concentric, distance, and then select other, coincident. Right mouse button, go on to the next. You can even repeat the usage of these earlier datum. So I could say, I just want the distance and the coincident to be the same as the previous selection, or as the original selection, and I want the concentric to be new. So this is going to be concentric here, right mouse button, concentric here, right mouse button. And now I don't want these to be the same any longer. I'm going to go up along this sidewall here. So I'm going to say I want the concentric this time to be this face here. I want the distance to be this face here. I can flip the distance mate so that it goes the appropriate direction. Maybe. I think I probably have to flip both of them. Yeah, there we go. And then I want the other coincident mate to be on this back side here. And then right mouse button, advance to the next one. It's going to be concentric down here. It's going to be distance from this one, and flip the alignment on both of those. And then it's going to be coincident on this back side here. So copy with mates is a huge time saver, definitely one to learn about. A lot of these tips we're going through pretty quickly here, so they may just be kind of an intro, but copy with mates is definitely a good one to learn about. It can save you a ton of time. Cool? All right, let's keep going. We're halfway through at the halfway mark. Anybody want to bail? That guy's bailing. See ya. All right, cool. We're good, I think. We're keeping everybody else in here. All right, let's see, what are we going to talk about next? All right, we talked about select other. That is a good one. We talked about quick mates. That's another really good one. That's one of my favorite enhancements in the software. Quick mates. How many people use quick mates pretty regularly? Where you pick one, hold control, pick the other. Okay, for the rest of you, it definitely bears repeating. So let me just show you one more time here. You bring in a component. So let's say this is my component here. You pick one face, you hold control, you pick the other face, you let go of control, and then boom, concentric. That's it. There's no check mark to hit. There's nothing else that you have to do. You pick one face, you hold control, you pick the other face, you let go of control, and you make them coincident. This is a really quick way to snap through your assemblies. Question? So you get it when you're doing, you don't get it when you're doing quick mates. That's what it comes down to. Yeah. So when you're doing the quick mate, you're not going to get the concentric. It's just going to default. But there's other ways that you can get it. Like if you bring up the regular mate command, you get it. Or I think if you do smart mates, you get it. So if I pick this face here. Oh yeah, sorry. So the question was, why does lock concentric not show up when we do quick mates? I don't know. Just try it, I guess. No, just kidding. No, it could be when the mate was created might play into it. It could be that maybe it's already locked with an angle. But I don't think that'll happen. I think if you do that, then the angle may just become suppressed. In those spots, I would just get the file from you, and then I would beat it up until I figure it out. Yep. Or we would maybe submit it to tech support. Another question in the back. Yeah, that's a great point. There's a newer functionality in the newer builds of SolidWorks where if you have two components which have mates between them and you do a Control-C, Control-V, or a Control-Drag. So if I do a Control-C, Control-V over here, these components now retain the mates that existed between them. That was an enhancement, I think, in, 2017? I think that's when they added that one. That's another great shortcut. And you can do that into other windows, too. You can go from one assembly to another, doing Control-C, Control-V into the other one. Another question here. I do personally because the Alt-Drag brings up that, oh, sorry, you're back. Yeah, so the question was, do you prefer the Control click over the Alt-Drag functionality? And I do personally because with the Control click, you're just pick one, hold Control, pick the other, let go of Control, mate, and you're done. Where when you do the smart mate, so if I pick this one here, I know there's different ways you can do this, but yeah. Pick this one here, and then you drag it onto there, and then you let it go. Then you get this dialog box. And I can't be bothered to go all the way up to here and hit the check mark every time. But you do get the lock rotation, right? Yeah, bringing it all the way back to the original question over here. All right. I probably would just control drag them once I bring them in, just do one of these. There's different ways you could do it. Like you could do a linear pattern and then you could maybe dissolve the pattern after it's created. That might be another way to do it. Yep. You could maybe have, yeah, those probably be good ways. Yeah. Yep, you can multi-select copy as well. Yep. So once you have a couple of them, then you could window these and then copy these and keep going, or Control-C, Control-V. Oh, great, here we go. We're going down the path. Okay. All right. Good? Keep going? All right, good. Excellent questions. Thank you all so much. Okay, copy with mates we talked about. Copy with mates is awesome. Control Tab, this is another one that I always see people doing with the window. You go up to the window at the top and then you use that to change your windows. But you don't have to do that. You just do Control Tab. So here's what I mean. You could go up to the top here and then you could say, all right, I want to get to this one, I want to get to this one. Right, but how are your files named? They're all named like 19002x53. And then you're like, I can't remember if that's the drawing or the assembly or, or like the number that you remember the project as is so far over that you can't see the number, you just see the ... right? So all you got to do is remember that if you hold your thumb on the Control key and then you bounce your finger on the Tab key, that lets you cycle through all of your currently open windows. And this is really cool because if I make a drawing of this, let's say, so file make drawing from part, what I really want to do is I want to bounce between these two windows primarily, right? I want to look at the drawing and then I want to look back at the part file. So I Control Tab, I'm in the part file, I Control Tab, I'm in the drawing file. I'm just pressing it once, I'm not holding it down. So what you're seeing here is that SolidWorks remembers the order of last accessed. So if I go over here and open up the bass guitar now, and then I do Control Tab, now the bass guitar is the first one in the list. And I'm just keeping my thumb on Control and then bouncing my finger on Tab. How many people like that one? Good? Yep, good. Thumbs up, hands up, everything. We got it. Party. No. So the question was, can you do that in a drawing between sheets? It's a great question, but what you can do is you can go to Customize and you can set up a shortcut for next sheet in drawings. So you go here to Keyboard and then I'm going to do search for sheet. And then you've got next sheet, previous sheet. So you can just go in there and then shortcut those to page up, page down. Good? Yeah, that's a good one, right? So yeah, page up, page down for switching between sheets. Another question? Okay, I didn't know that. Control arrow works for switching between pages. That's cool. I did not know that. Cool, good to know. All right, cool. How are we doing for time? 23, okay, we got 37 minutes. All right, are you leaving? Okay, all right. I'm not. Okay. All right, here we go. Copy with mates. Oh yeah, so we could use copy with mates here as well, just to copy these screws across the pick guard. Or again, you could use the pattern-driven pattern in that spot too. That's probably what I would do in that spot, would just be pattern-driven pattern. Okay, that's heavy, right? This is a pretty cool illustration of the bass guitar. Now, I know there's probably not many people who have had this happen, so this might just hit a subset of the room, but has anybody ever worked with an assembly that goes slow? Okay, a couple people. All right, good. So So why do assemblies go slow? I actually have another YouTube series on this. It's called Large Assemblies and How to Make Them Faster. I think that's what it's called. But if you just look up Toby or Toby Schnarr's assemblies, you'll find the series. It's 153 minutes long. So it's like a full training class for free on YouTube on how to do better with assemblies. But the biggest thing that you can do is you can learn how to use this tool here, assembly visualization, and then you can learn how to use the graphics triangles filter. So the reason why assemblies are slow is not a straightforward answer because different people can imagine things being slow in different ways. For example, it's slow to open versus it's slow to work with. If it's slow to open, it means that you're either loading too much data, it's loading too slow, or most commonly a combination of both. So you've got these massive data sets and you're loading them across a network onto a mechanical hard drive, for example. If it's or into slower RAM actually would be more appropriate for that one. See, I shouldn't have gone down this road. Anyhow, let's stick to the one we know. So if it's slow to work with, a lot of times what you're doing is you're overtaxing your graphics card. So it's important to be able to find out why your assemblies are overtaxing your graphics card, and that means identifying which components are the heaviest in your assembly. So if we go back to our assembly here, we can go to Assembly, Evaluate, Assembly Visualization. It's called Assembly Visualization. It's on the Evaluate toolbar. Move over here. Evaluate toolbar. And what Assembly Visualization does is it reorders the assembly tree based on a set criteria. So I'm going to click Assembly Visualization, and you can see all the different criteria by flying out this menu here. So for example, if I set the criteria to mass, then it's going to show me the heaviest parts in one color, and it's going to show me the lightest parts in another color. So here's mass, and you can see I've set up my filters over here on the left. You can change all these colors. There's all kinds of cool stuff that you can do with this. But if you go into More, and then you fly out this menu here for the selected property, you'll see all of the different metadata properties you've assigned to your components, like cost, or if you wanted to sort by SKU or something like that for some reason, you could do that. And you'll also see some other ones that are really handy, like graphics triangles. Now, I already have a column for graphics triangles, so I just have to go grab it from here. So what this is showing me is it's showing me which components have the highest number of graphics triangles. So what causes a high count of graphics triangles? It's curvature in your models. All right, so let's say you've got a screw with helical threads. That's going to cause an intense taxation on your graphics card. Let's say you've got springs in your models. That's going to cause intense taxation on your graphics card. Let's just say you have components that have the image quality dialed up. That's going to increase the number of graphics triangles in your assembly. So there's all these little things that you can do to drive this number down, but this is where you can go to look to see why your assembly is too heavy. In this case, you can see that this first component here is a very heavy component. Let's open it up and take a look at it. It's a spring, okay? And it was at, I think it was at 49,000 graphics triangles. So like I said, I mean, one thing that you can do as like kind of a stopgap a little bit is you can just go in here to image quality and then kind of drive this down a little bit. So if I drive this down a little bit, let's say we drive it to the middle here, the spring still looks pretty good. I'm going to save this, go back to my assembly, and then I'm going to rebuild, and we'll see if that came down at all from the 49,000. So you have to come back in here and rebuild. I usually will just do a Control Q to rebuild it. And then you can see, let's see, where is that component? Spring. Oh, I don't know which one it was, actually. So this isn't going to help me. So yeah, we drove that one down. It's no longer in this top grouping of components. So yeah, I mean, that's the basic idea here, is that you can drive down the number of graphics triangles by doing what? Not by changing your image quality, but by going in and making simplified configurations, right? Don't use a helical thread on a tiny little part if you're building a battleship, you know, and you're using that part 1,000 times over. You're going to crush the performance on your graphics card, and you're never going to see those threads. So make a configuration that looks really good when you're doing marketing content, when you're doing drawings, when you're working with the sub-assemblies. But when you get to the higher level assembly, just make that a straight shaft. You know, if it's a spring and you're working at a higher level assembly, just make it a cylinder, just make it a sleeve. And that's going to significantly cut down on the taxation on your graphics cards, and it's going to make your assemblies much nicer to work with. Okay? So the lesson there is understanding how to go into evaluate, assembly visualization, and starting to look for these heavy components. Okay, a couple of hands went up. I saw a question in the back. So in that scenario, I just did the cheapy method. I just went in and, so like, let's look at this guy here, okay? So this component, why is this component so high in number of graphics triangles? It's got 45,000 or 42,000 graphics triangles. All it is a strap lock button. Why is this so high? And this shouldn't be that high in number of graphics triangles. So the first thing I did was I just went in here to document properties image quality, and then I just brought this down a little bit, and that's going to decrease the tessellation of that part, or actually it'll increase the tessellation, right? And then we're going to go back here to, would it be decrease? Andrew, is it decrease or increase? What am I doing? I don't know. Forget it. Go back to your work. All right, so now we're going to click on this component. We got to rebuild to have this thing update. Now we're going to click on this component, and we see we brought it down to 14,000 just by doing that, from 42,000 down to 14,000 graphics triangles. I mean, to put things into perspective, if I'm working on a large assembly, I'm trying to keep all my components under 1,000 graphics triangles. I have this 3 levels of qualification. Everything under 1,000 graphics triangles, anything between 1,000 and 5,000, and then anything above. And there shouldn't be too many components above 5,000. If I have a really weird, like swoopy, lofty casing that the customer is going to see, all right, well, I got to deal with that. But everything else I want down below. I've seen people import models and they're 1,000,000 graphics triangles, one part file. And then they bring that into their assembly and they're like, why are my assemblies so slow? It's like it's an import of a bus and they're making like the mats that people don't slip on. And they're like, SolidWorks sucks. It's slow. It's like, well, you're bringing in 1.5 million graphics triangles. You're just slowing down your computer a little. So just, you got to look out for those things. Now, if I was going to take it a step further, if I was consulting with a customer to try to get their performance to be better, then what I would do is I would go in and make a configuration. So I would do add configuration here and then make a simplified configuration and start cleaning things up. If it's a model that has a feature tree, that might just be as simple as going in here and suppressing some of these fillets. But if it's not a model that has a feature tree, if it is an imported model, then this command, insert face delete, is going to be your best friend. Because what insert face delete does is it gets rid of this face and it does a surface extend on this top face and on the cylinder face here and patches those two together. So even though I don't have a feature tree for this model, I can go in and I can start deleting fillets out of the model and cleaning up that model and reducing the curvature. Insert face delete. But like I said, fortunately, nobody ever runs into issues with slow assemblies, so we can move on and talk about some other cool stuff now. All right, let's take a look at, question. That's a great question. You have to do it at the assembly level. So the question, thank you. So the question was, can you check the number of graphics triangles at the part level? No is the answer, not as far as I know. What I usually will do is I'll just make a new subassembly from part. So let's say I have an engine housing and it's 1,000,000 graphics triangles and I want to try to bring it down. What I'll do is I'll take that part file and then I'll go file, make assembly from part. And then I'll just drop in that one single part file and now I can do assembly evaluation on that part file. They're very similar. The question was, are those different from the triangles that you get when you go here to File, Save As, STL? They're very similar. So when you go to Save As STL and then you go into your options here and you drive this, a certain location, and then you hit OK, and then you just save this with this name. You see these graphics triangles here? They're very similar. It's a good question, but no, it's not an exact one-to-one because when you save as STL, you're specifying with that slider how detailed you want the curvature to be. In the case of SolidWorks, it's actually more driven by that document properties image quality slider. Another question over here. I think in the new versions, let me think. In the new versions of the software, they've added not a graphics triangle function, but they've added this function of assembly performance evaluation. So here in the SolidWorks assembly file, you can see that there's an option here for, what the heck was it called? Evaluate performance evaluation. So this gives you some other info too. Like I've said in the beginning, sometimes assemblies are slow to open, sometimes they're slow to work with. So as we're going down through here and we're looking at this assembly, these are the components that are taking the longest to open. So if one of those components is like way outside of the norm, you might want to look at where that component's coming from. And you'd be like, oh, this is from my old 64 meg flash drive. That's why it's going so slow in USB 1.0. That's like a contrived example, but more likely it's coming from a slow network location. So you can help identify that, and then you have this display performance down here. So if we go into drawings in SolidWorks 2019, they've added a similar function in drawings. So we go here to evaluate, and then we go to performance evaluation. And then you can see they've added a similar information like which views are taking the longest. I haven't worked with this one as much, but you can go in and look at that one. Yep. Another question. You can force it to rotate about a certain point. What happens is SolidWorks looks at the body envelope of whatever component your mouse is closest to, and then like see how the bass guitar highlighted in magenta there? So what you can do is you can single mouse click on an edge or a vertex. Single middle mouse click on an edge or a vertex, and that like kind of assigns that edge or vertex to be the rotation point. So we go here to, let's say we go here to this guy. What the? Whoa, no, it's okay. No, we're good. So we go to that point there, and then we rotate about that point there, and I'm tapping it once and then holding it down. So I think that edge has curvature. That's why it's not letting me pick that edge. Nope, that one does too. Me and my splines. Okay, there. So now you can see I'm rotating about that edge that I selected. And if you do that same thing, if you tap it at first, just once, and then you rotate about it, then you kind of like tap it to preload it. Yeah. You just wait for it. Yeah. And so Mark, shout out to Mark Johnson, who's one of the wizards of tech support at SolidWorks Corporate. The dialog box that you get, the white screens, isn't a SolidWorks dialog box, it's a Windows dialog box. It's Windows saying the application isn't coming back. It's not SolidWorks saying I'm crashing. It's Windows saying the application is tied up right now. And so what Mark Johnson did with 2019 is he actually put in a different front end on that dialog box. It says SolidWorks is busy. Here's how much RAM it's using. It's still working. If you just wait a little bit, it'll come back. Yeah. Shout out to Mark Johnson. He's awesome. Yeah. Shout out. Yeah. Mark Johnson. Yeah. We love Mark Johnson. Yeah. All right. So let's see what else we got here. What else can we talk about here? Oh, one last thing, fit spline. We love fit spline. Fit spline is like the greatest command in the software ever, except for the S key and Quickmates, and that's it, just the S key and Quickmates. So here's fit spline. So how many people have ever worked with splines just in general? So quite a few of you have worked with splines. So for those of you who haven't, this is a spline tool here. The trick to working with the spline command is just don't put in too many points. Like if I'm trying to make this basic shape here, this is just a 2-point spline, and then I'm gonna utilize these handles here to get the desired result, to like kind of follow that spline there. That's just 2 points. You know, how would I have done that when I started using SolidWorks? I would have done like this. Up here, right? That looks good, looks really good. Right? And then it gets really lumpy. So instead what you do is once you create a spline, you just create the spline with as few points as possible. If you need more, you can always do a right mouse button and add them. You can also click on them and delete them if you make too many. But then you grab these handles here and you reposition these handles. Okay? Now, what fit spline does is really cool. Fit spline lets you create existing geometry, maybe even fully define that existing geometry, and then you go to the command tools, spline tools, fit spline, or shout out to Andrew in the back of the room. He knows how to come up here to the top, and you can search for a command, and then you just click on it, and it launches the command. So anytime you need a command, if you want like a little placeholder, you can use this up here. So fit spline, instead of going and finding it in the menus, I can just go up to the top here and type that in, FIT, and then once you hit enter or search here, then it shows up. And now that's going to be a little placeholder for that command. So maybe I'll use fit spline once here, then I'm done with it, do some other stuff, then I'm going to come back later and use it again. I just click here, and it's like a temporary icon, right? I saw you doing that when we were working that one day on the project. Yeah, nice job. I was like, this guy's the bomb. So what fit spline does is it lets you pick a series of entities, and then it traces over those entities with a spline. It lets you say, so it's kind of like a convert entities, but convert entities into a spline. And there's a lot of applications for this. It's great when you're creating loft profiles and you want them all to have the same number of entities. So now you can see that has one single entity, which is the fit spline. You can see I can zoom in here, and there's a little bit of curvature there, kind of zoom back out. Zoom in here, there's the curvature. But the other thing that fit spline does is it'll actually let you jump gaps with a fit spline. So what I mean by that is if I have a line here, and let's say it's in a 3D sketch, and then I have another line here that's in a 3D sketch, and it's kind of hard to figure out what the transition is going to be between those two lines, I can go to fit spline. So I'll just do a little click up here, fit spline, and I can click this guy and this guy, and then I can jump that gap. Fit spline. Pretty cool, right? So a good application for this would be transitioning into a helix. Question, Robbie. I mean, it's technically curvature, not tangency, but yes. Yeah. It's one entity. It's not 3 entities anymore. It's one single entity, yeah. Yep, question? Yes. Well, I mean, when you say weldment, are you saying specifically the structural member in weldment or just the sweep in general? So the question was, can you use this as a path for a weldment? I'd have to try it. I mean, I would assume you can, but I would just have to try it. I don't know if, I don't know if I did it well, let's just try it. Forget it. Why am I talking? Yeah. All right, so let's just pull this guy up over here, and we'll pull this guy like that. That'll look really good. So you can see here that the fit spline will retain a relationship to the underlying geometry, which is cool because that means now you can dimension these entities and lock these entities into place. So let's go here to structural members. And then we're going to go to the type. And then we're going to pick here. No, it's not letting me do it. All right, good question. So I guess splines are excluded from weldment profiles for those selections. Yep, good question. So you'd have to draw it up and sweep it along there. So the question was, how do you fully define splines? And the answer to that question is, it is possible. It's often not necessary because of the scenario that we use splines in. You know, a lot of times it's like consumer product design or whatnot. But what you do is you do it the same way you would do a regular sketch. You have to lock down all the points and all the degrees of freedom. Now, it actually goes beyond that because you have the ability to define things like angles for the spline handles. So, for example, if I go to the spline command here and I draw a spline that goes from here to here, the sketch is underdefined currently. But if I take this point and drop it onto this endpoint, the sketch is fully defined. By the way, I'm looking down here at the status bar. So you can see the sketch is fully defined now, right? But the spline is still able to be manipulated by these handles. So I can drag these handles here, but it still says that it's fully defined. So what do we have to do beyond that? Well, we have to control the angle of this tangency handle. So if I click on this tangency handle here, I can actually go over and assign either an angle dimension or a horizontal relationship. But we're still not done, because it's not just the angle of tangency, it's the magnitude of the influence of that handle as well. And you can define that as well with a magical number, and I have no idea what this number represents, but if you increase it or decrease it, the magnitude of tangency at that location will change. I don't know, was that 15 inches? Is that like 15? I don't know what that number is, but I know that you can use it to lock down splines. So that's the answer. That's how you properly fully define a spline, is that you define the angle of tangency handle magnitude, and then you define the magic number, the magnitude. Okay? Good? All right, cool. And you could define the length of the spline. You could use there's a lot of other cool spline tools you could use, like the style spline lets you use your traditional, with this, what you do is you define these points and these lines using angles and things like that to fully define it. Yep. Splines are awesome. We could talk about splines the rest of the time. 18 minutes, I could fill it up, no problem talking about splines. All right, let me show you an application of this, though. You can see this guitar is missing a string, unfortunately. This is a new guitar company. I'm going to start competing with you, Andrew, so I made my own custom logo. You can see here that I've got my option for sketches turned on. I just need to go through to some of these parts to show you kind of how I set up the layout for this. So, for example, this part here, I created a sketch called string path. So there's the string path for that sketch, for that part, I mean. And for this part here, I created a sketch for where the hold downs are coming through. So here's this hold down. And of course, I'm using sketch colors there as well. For this part here, I created a path where things are going to be passing through the nut here. Here it is. Okay, so this is just like routing. I'm just setting myself up ahead of time because I know I'm going to be routing things through here. You notice how I say that? Like, everybody uses routing, right? Everybody knows all about routing. Routing's great. All right, and then this part here, I'm going to show this one. Okay, and then there's one more. I didn't change the color on that one. Maybe I should. All right, so I'm going to go right mouse button, sketch color. Just make that something that really pops out so it's easy to select. All right, and then one more here. This guy here, I think that's where I put the last one. Yep, right there. Okay, so now I've got these sketches shown, and I want to route between them. So how am I going to do the route between them? Well, I'm going to start out by editing this part. and then I'm going to create a new 3D sketch in that part. So I've got a single part file that represents the 4 strings. I'm going to create a new 3D sketch in that part file, and that 3D sketch is going to be of a line that goes from this point here, I'm going to just go from the end point, up to this connection point here on my route. I'm just going to drop it right there because I'm going to actually jump that gap using the fit spline command. So now I'm going to go from this point here all the way up to this location here. All right, and again, I can just jump that gap. I don't have to connect those 2 endpoints. So now I'm going to go from here down to this point here. And for this one, I probably could just go straight through or do a convert entities to get through to that one there. Now, the final entity, the final element that I need to create here is the helix. I forgot to create it ahead of time. So let me just create that now. Okay, done. So we created the helix. Nice, right? All right, so now let's go back and edit that 3D sketch that we were working on. And we're going to take that helix and we're going to do a convert entity. So we're going to convert that into the 3D sketch. And we're going to take this geometry here from the sketch that's going down into the tuner. And we're going to convert that as well. Or the machine head. How many people call these things tuners? How many call them machine heads? How many don't care? Okay, and we're going to go here to the, what I'm going to do for this last one is I'm going to create a little bit of a gap here between these guys. So I'm just going to create maybe a line that comes straight down a little bit. So I'll go here into the XY, and then I'll create another line that just kind of comes over this way a little bit. And this is just going to be to help facilitate that idea of merging that tangency to that gap. So just a little something like that. Fully define that, of course. And it doesn't even have to be for construction. I just do that to help remember. And then I'm going to create another line that goes from here to here. And that is my layout for my fit spline. So now I'm going to exit that sketch. And now what I'm going to do is I'm going to do another 3D sketch. And in this other 3D sketch, I'm going to do a fit spline. Now this is where it gets really cool. If you ever have to transition from a straight entity into a helix, the fit spline will let you jump that gap. Pretty cool, right? I don't have to draw in that transition. I'm going to go from this location at the end of the helix over here into the section that's going down into the machine head. Pretty cool, right? I'm going to come over here to this region. I'm going to go underneath that hold down. I'm going to go through this section here. I'm going to jump the gap again. So the spline just jumps right over that gap. And then I'm going to come down to the end of this thing and just finish this guy off. So this is the real power of using fit spline, is that you can get into this kind of cool functionality. You can adjust this slider here, which is going to adjust how tight or how loose the spline will hold to the original geometry. But in the end, what we've got is we've got this 3D sketch now that we can just click on in our graphics area or in the tree, and then choose the command feature sweep, and we can say we want that thing to sweep with a circular profile, and we'll make that 45 thou. And hope for the best. Boom. Pretty cool, right? Pretty cool. So it just sweeps all the way up in there. I'm going to poke this guy in the eyeball up top here so he hides everything, so everything looks good. And look at that transition into that helix. How many people have ever tried to do that transition into a helix in a 3D sketch? One person? No, okay. A few people, yeah. It's a good one to know about that fit spline command. All right, cool. Let's keep going on here. Okay, we talked about the search for commands, so I said, okay, one more thing, search for commands. Okay, for reals, last thing, right? But I actually have like a million other slides after this, but I know we're not going to get to them. I knew we wouldn't ahead of time. This is just another one that I think is an amazing shortcut that everybody should know about. So S key, click on this face here. I'll make this guy 3 by 6, and S key extrude, and we're going to bring this guy up like so. And then if you go to the fillet command in SolidWorks, whenever you click on an edge, you're going to get this little menu here. Take time to learn how that menu works. Okay, so I'm in the fillet. The way that this works is I begin the fillet command. I single click on an edge, and this little menu shows up here, up to the right. And if I just hold my mouse over it, SolidWorks shows me what it's going to fillet. So for example, if I pick this first one, it gets all 4 corners in one shot. Now this is another one of these workflows that I always try to teach my students. You begin the fillet command, you type in what you want the fillet to be, that's the first step. You single click on this edge, you move your mouse up, and you single click on this icon. And now look at your mouse. Your mouse is saying, if you right mouse button, that's the same as hitting OK. If I right mouse button there, it's the same as hitting OK. I finish the command. You want to always look for those little shortcuts and just force yourself to practice using them. If I pick this face here, I don't have to go up to the sketch command and click sketch up at the top there, like switch to a different menu. I just pick this face, and then I pick the sketch command right here. Okay, I do a Ctrl 8, I get normal 2. Let's say I create a rectangle. I've got my auto dimensions showing up when I go to create geometry in sketch mode. So I just type in my values there. If I go S key and jump into extruded cut, I can do a right mouse button in the background, and from the right mouse button in the background, I can choose through all, and then look what happens. My mouse changes, again saying if you hit the green check mark, that's the same as hitting OK. So I don't have to take my mouse all the way up here and hit OK. So look for those shortcuts. Try to learn those shortcuts. They're really good ones. So that's a good question, and I'm gonna get to that in just another minute. But I got one more thing I want to show you before I do. Kind of a shameless plug for a project I'm working on. So this is a back massager that my roommate gave me. She's 9. Okay, she's my daughter. She got it at school. So it's a back massager. So what I did was I took this back massager and I put it into SolidWorks Cell. So if you have a mobile device and you want to take a minute and you want to put down that address, I would love for you to take a look at this project. If you have an Apple device, you can actually get this thing to show up in augmented reality. So you can bring up this website, you can point at a planar surface, a table, and you can see what this object looks like on the table. It's really cool. All right, it's a really cool new product that we're working on at SolidWorks. It's called SolidWorks Cell. You're going to hear a lot about it this week, but I figured I just would take a moment and kind of show you guys what this looks like. And the really cool thing about this is that this only took me about 5 minutes to get up onto the website. You know, maybe 10 minutes to go from having a SolidWorks model to having this thing up on the website. So if you get a minute, what'll happen is you'll have the object on your Apple device or on your Android device. On your Android device, you can still get in here and you can click the main color and change the color of this back massager. You can rotate it around. You can change all the different colors here. You can change the color of the fork. And then if you have an Apple device, you'll get a little AR up here in the corner. And you click on that AR. And then I know it's hard to see from the back, but I'm doing cool stuff up here, I promise. All right. And so with the AR device, you can see that you can rotate this thing around. I put it in a position where it looks like it's sitting on a table. And then what you can do is you can hit this button that says AR, and then something really cool happens. You point it at a planar surface, and the object will actually show up there on the planar surface. Yeah, really. You want to see it? Come on up, Robbie. I'll show you what it looks like. No? Okay. All right. But I can see it. It looks like it's sitting right here. Looks like it's sitting right here. I can see it. Okay, so this is a really cool thing you can check out. If you want to talk more about Cell, just come up and you can talk to me after the presentation. But this is another area that I'm working with an amazing team on, the SolidWorks Cell team. And this gives you a chance to see that right away, see how you can configure stuff. And what I did was I went from having a SolidWorks model to posting these models up on the website. And this whole process took about 10 minutes. It's not like a super elaborate. You're going to see an amazing example of this tomorrow. It's not a super elaborate with like 100 parts or anything. We can do that. It's just a real simple one, but I just kind of wanted you guys to see what you can do with SolidWorks Cell. So with that, to kind of roll things out, to finish things up here, we're going to go back to the beginning. We're going to talk about in the beginning. So what happens with SolidWorks when you're working with SolidWorks is that you have all your settings coming from the SolidWorks registry. And if you want to learn more about the registry, I've posted a video about that on YouTube as well. You just look up Toby registry, and you'll learn all about how to use the SolidWorks registry. But I officially advise you not to use this, nor to learn anything about it. This could be a great way to go in and blow up your computer if you go in and start messing with your registry. But what the registry can do is it can help you out of situations where maybe you have incorrect icons, maybe icons are missing. Maybe you're pointing at the wrong directories in SolidWorks, or you've got instability and crashing. So basically, if you go in here to your options under file locations, you should be pointing to all your SolidWorks 2019 libraries and locations. If you're not, it could be that your registry is messed up. So what happens is when you first launch the software is going to create what's called a new registry key. When you first install the software, it's going to create the registry key actually, but when you first launch the software, it's going to create a new one. And by going into the registry, we can actually trick Windows into thinking we've never launched the software as this user before. So I'll call this one SolidWorks World. Okay, watch the video because I explained how to do this and how not to mess yourself up. But what I just did was I gave myself kind of a hard reset of SolidWorks. I put myself all the way back to the very beginning, to the very first time that I installed the software. And I wanted to do this during today's presentation because I wanted you to all see the way that I set up SolidWorks when I do a new, fresh install. And that's going to pretty much bring us up to 12 o'clock. So we're coming to the end here. I know the time went by fast. I'm going to miss you guys. Been together so long here. All right, so here are the things that I do. I'll show them to you here in the PowerPoint, and then I'll show you how I do them. Which one? That's a memory leak. You got to look up memory leak. Something's leaking memory. It's probably not SolidWorks too. It's probably something else on your computer. It could be SolidWorks, but I have it happen on this computer, and I don't have it happen on my other computer, and they're set up the same, except they're different manufacturers of the computer. So it's called a memory leak. It's basically Windows is supposed to release memory back into the cache when it's done using it, and it's not. There's certain programs that don't release it properly. So it's called a memory leak. Question? I mean, that's another issue too, but I don't think we're going to have time to talk about it today. The question was, what about GDI objects? That's like kind of how much visual information Windows is juggling simultaneously. Question? I can't talk about it right now. I don't have time. I'm going to get jammed up with time. But I can talk to you. I can actually probably put you in touch with the right people to talk about it. I actually don't beat that up that much because I haven't run into it as much as some other people. Yeah. But I know that people do run into it. All right, so you're not crazy. All right, so let's just go through here and talk about what we set up. So what I do when I set up is I set up this little push pin, hit this little push pin. I turn all my add-ins off that I'm not using. I set up my S key. I set up my colors. I set up sketch mirror on the context bar. We can talk a little bit about mouse gestures. And I add auto sketches, which is right here, auto dimensions in sketches. All right, so let's take a look. I'm going to go here to this little flyout menu. I'm going to hit this push pin. That way these menus always appear. A lot of times I'll start a new, how do you stop this one? Hey, how do you stop this error? Check virus protection. Can you help me with this one? He's not looking up. Hey, excuse me. How about this one here? Can you help me with this one? I keep getting this. Okay, thank you. All right, yeah, we need to fix that one too. All right, so we're going to go here to a new part. Let's talk about some other things that we set up. We go through and we set up our add-ins so that all of our add-ins aren't running. I'm going to abbreviate some of this just because we're running down the clock here. I'm going to let you guys go right at noon, I promise. But if you do have questions when we're done, come on up. I'd love to talk to you. Or if you just want to talk. It's only lunch, you know. All right, so we go here to our setup for our colors next. So I like having the actual old school SolidWorks colors. They're called the classic colors. I think it's just a little bit easier to navigate through when you can see that your sketches are blue and that your features are green and yellow. That's just me personally. That's why it's an option. So if we go into options here and we go to colors, we can set this to classic and then we can set this to medium light. There's my colors set up properly, the way that I like them. Then what we can do is we can go to our options, and in our options we can go down here to sketch, and we turn on these two options right here. So we go down here to options, we turn on these two options right here. Enable on-screen numeric input and create dimension only when a value is entered. And so what this does is whenever you're sketching, you click a face, begin a sketch, orient your view. You hit the S key and you choose the type of entity you want to create. Let's say I want to create a circle. You single click, and then you move your mouse and you let go. You single click, you don't click and drag. If you click and drag, this isn't going to work because if you type in a number and then move your mouse again, you're going to lose the number. So you just single click and then you move your mouse and then you let go, and then you go over to your 10 key and you type in the number that you want that to be. Oh, I'm in millimeters, huh? Let's try it again. Single click, pick the entity, move away, 25, enter. And now you've got that nice fully defined circle ready to go. If it's a rectangle, you can do single click rectangle, and then you can single click, move your mouse, type in the first number, enter, type in the second number, enter, and then you've got your fully defined rectangle. And it works with a lot of different entities, and you can do some cool stuff with it too, like with a rectangle, if you define one with a number, but then for the other one, like you drop it coincident to an edge, it'll honor that. It'll give you like coincident for the width, but it'll give you the dimension for the length. So there's all kinds of cool stuff you can do with that. And I think that's a shortcut that everyone can use. So I think that's probably where I'm going to end. I do have just a couple of quick wrap-up slides. The first wrap-up slide is simply to say you have to force yourself to practice and learn these new tips and tricks and workflows, right? When SolidWorks first came out with some of these tools, I didn't use them. When they first came out with the click on a plane to start a sketch tool, I never used that. I was like, I don't need that. I'm just going to, I'll pick the front plane, and then I'll come up here, and I'll pick sketch, and then I'll pick the sketch command. When SolidWorks first came out with this thing, the command manager, my toolbars were all over the place. I didn't want the command manager. I don't want to use that. The command manager is awesome. Your screens don't jump all around when you're switching between windows. Being able to start a sketch by going here and then just picking sketch is so much faster. But you got to force yourself to practice and learn these new techniques, to learn these workflows. Think through how the workflow is going to go. You're going to pick a sketch. You're going to extrude it. Right mouse button. Look at what the background options are. Look for up to next. Look for that little right mouse button that shows up on the mouse icon for the check mark. It's going to save you so much time. So one last thing I just want to say is I am on LinkedIn. I'm on YouTube. I'm on Twitter. I'm on Reddit. Please stay in touch with me. You can reach out to me anytime if you have questions. I'll try to post this presentation on my YouTube channel tonight, so you guys will have all the notes and all the good information from this. If you have any questions, come on up. Otherwise, I want to say thank you very much, and please remember to fill out your survey. This is my last thing. Please remember to fill out your survey. It's not even in there. Forget it. Please remember to fill out your survey. Thank you all very much. Enjoy SolidWorks World 2019. I hope you guys have a great week. Come on up and talk to me anytime.